This lesson is on polynomial identities. Polynomials are expressions consisting of addition and subtraction of variables, and coefficients all raised to non-negative integer powers. As in the last few lessons, there can be a single variable or multiple variables. So, in exercise 1, they want to know which of the following is not a polynomial expression. Explain why your choice fails to be a polynomial. So, based on the definition above, it has to have integer powers. So, number 3 does not have an integer power. It fails. All the rest of them are addition and subtraction of variables, have coefficients raised to non-negative, and integer powers. Okay? All right. Because again, negative we can make into positive. Okay? So this would maybe be another reason. All right. So there's no division. All right. Because polynomials consist of basic operations on variables, they can be manipulated using the associative, commutative, and distributive properties, as you have done many times. If you don't know those 3 properties, then please go and look them up. All right? These operations can result in what are known as polynomial identities. An identity is defined more broadly below. So an identity is an equation that is true for all values of the replacement variable or variables. And guess what? We do this all the time. This is how we check our work on our calculator. We substitute a value and we check the left side. Does it equal the right side? Does the expression equal the answer when we plug numbers in? And that's what we're doing. We're all picking a different number. So we're using this idea of a polynomial identity. All right? Exercise 2. One identity that you should be familiar with is x squared minus y squared equals x minus y times x plus y. So that is an identity because any number we put in for x and any number we put in for y, when we do this, it always works. It always comes out true. So what are they telling us to do? Test it. So if x is 10 and y is 3, that means I have 10 squared minus 3 squared equals 10 minus 3 times 10 plus 3. So 10 minus 3, or 10 squared minus 3 squared is 100 minus 9, which is 91. Does that equal 10 minus 3, which is 7, times 13? Plug it in your calculator, or if you just know it, yeah. So it works. So it says, prove this identity by manipulating the right side of the equation. So that means do the math on the right side. So x squared minus y squared, does it equal x minus y times x plus y? So if they're telling you to prove this, they want you to do the math, okay? That might be a question. Prove x squared minus y squared equals x minus y times x plus y. So we can't do necessarily anything here, but this question tells us to do the right. So we're going to multiply. So you could do your box off to the side, or you can just double distribute. So x times x is x squared. X times y is xy. Negative y times x, put your letters in alphabetical order, is negative xy. And then negative y times y is negative y squared. Notice what happens to those middle 2 terms. This cancels with this. They undo each other. They're opposites. So x squared minus y squared. Yes, it equals x squared minus y squared. Okay? So now, to make it a little bit harder, now they're telling you to use this identity to evaluate the difference. Okay? Uh-oh, here comes our friend. And there's Rosa. All right, so we're going to use this 50 squared minus 49 squared has to equal, well, that means x is 50 and y is 49. Okay? So, what is 50 minus 49? 1 times 99 equals 99. Well, did you know that when we wrote it down? If you want to make sure, plug that in the calculator. I didn't know that. That's pretty cool. Now they're giving us the different question in a different way. But think about it. Use this identity to simplify and then evaluate the product of 51 times 49. So that's one above and one below 50, right? So they're giving us now the right side. So 51 times 49 equals 50 plus 1 and 50 minus 1, right? So this is x plus y, and this is x minus y. Oh, here she comes again. So 50 plus 1, oh, we want to go backwards. So if we know this, then we know x is 50. I see. So now we want to do, I should have left more room over here. So this is the same as, okay, so this is the right side. So now I want to go to the left side. So if I know x is 50, this is 50 squared minus y is 1, so 1 squared. 50 minus 1 squared is 2,500 minus 1, which is 2,499. Again, this is the way some people do math quickly without a calculator. And it all goes back to the identity that we call the difference of two perfect squares. Okay? All right, so again, if that's overwhelming to you, pause, look it over. If you have questions, write them down. If there's parts you don't understand, star them, and let's go over it next class. If you're good, let's do exercise 3, which is another identity that we should know. So, prove the identity a plus b in quantity squared, in parentheses, equals a squared plus 2ab plus b squared, and then use it to evaluate 35 squared. So we have two problems here. So they told us to prove this identity. So we have to do math. So I'm going to do the math on the side that says squared. So squared is a plus b times a plus b. And I have to get it to equal this other side. So again, I can use the box on this, or I can double distribute. A times a is a squared. A times b is ab. B times a, put them in alphabetical order, a, b. B times b is b squared. Combine your like terms, so notice these two in the middle can be added together. So I have a squared plus two of them, so 2ab, remember there's a 1 here and a 1 here, plus b squared. Does it equal a squared plus 2ab plus b squared? So I'm good to go. So how am I going to use that to evaluate 35 squared? Well, 35 is this number in parentheses. So a plus b quantity squared equals a squared plus 2ab plus b squared. So 35 is the sum of what two numbers that are maybe easy for us to do math in our head without a calculator on? Let's try 30 and 5. Could I use 20 and 15? Sure. Okay. So that means a is what? 30. So 30 squared plus 2 times 30. B is 5. All right. So 30 squared is 3 squared, which is 9, and then 2 zeros, right? All right. And then plus 2 times 5, because that's easier to multiply, is 10. 10 times 30 is 300. plus 25. So 900 plus 300 is 1200 plus 25. So 1225. So there's how I evaluated that. I could see them doing something like this on the regions, of course. Okay? So prove something and then use it. Maybe a 4-point question or a 2-point question. I don't know. All right? All right, let's look at the next page. We're going to use some geometry. So sometimes identities can have geometric connections as well as algebraic. Pythagorean theorem gives us ample identities. So do we know Pythagorean theorem, hopefully? So Pythagorean theorem says a squared plus b squared equals c squared. But the part you really need to remember is it has to be a right triangle. Okay? All right. So in exercise 4, we have a right triangle, and the sides are 2x, x squared minus 1, and x squared plus 1. They want us to show that these will be the side lengths of a right triangle as long as x is greater than 1. So we have to show or prove this identity. Well, what are some things we know about Pythagorean theorem? Okay. The hypotenuse, which is across from the right angle, is the biggest side. Okay. So that's why it's equal to the sum of the other two sides. All right. So let's do some math. We said Pythagorean theorem is a squared plus b squared equals c squared. Guess what the hypotenuse is? C. A and B don't matter, so let's call this one A and this one B. Okay. Oh, look, they even set it up for us. So I'm thinking in the future, since you should know Pythagorean theorem, they don't even have to set it up. They could just give you this picture and say, prove this triangle using Pythagorean theorem, or just prove this triangle, or show the identity, something like that. So 2x squared is 4x squared plus, when we square this, we write it twice, which means I'm going to use a box because this gets a little bit not very nice. So x squared minus 1, x squared minus 1, so x to the 4th minus x squared plus 1. So we have x to the 4th minus 2x squared plus 1 equals what's on the other side. The one thing you have to remember in an identity is you cannot move things from the left side to the right side and right side to left side. You're, in essence, having two problems and you want to see if they equal. Okay? I'm trying to find the answer to this side and the answer to this side, and are they equal? Okay? So on the other side, we have x squared plus 1 squared. So I have x to the 4th, positive x squared, positive x squared, positive 1. X to the 4th plus 2x squared plus 1. So on this side, I can do some math, combine some like terms. So x to the 4th, these are the like terms. So plus 2x squared plus 1. Does that equal x to the 4th plus 2x squared plus 1? Yes, it does. Sweet. All right. So that means we are done. All right. If we picked any number for x and plugged it in, as long as x is greater than 1, this identity, this Pythagorean theorem would work. Okay? All right. So yeah, okay, part B. Based on our work from A and on the triangle shown, explain why any even integer other than 2 must be part of a Pythagorean triple. Ooh, that's a special word. I.e., a set of 3 integers, so integers, that could be the sides of a right triangle. Generate a Pythagorean triple that has 10 in it and a separate one that has 14 in it. All right. So it says a Pythagorean triple that has 10 in it. So I think the easiest one to start with is this. So if this side has to be 10, so my sides are 2x, x squared minus 1, x squared plus 1, right? So if this side has to equal 10, then x is going to equal 5, right? So that means this side, 5 squared is 25 minus 1 is 24. And then 25 plus 1 is 26. So does that work with Pythagorean theorem? All right, so let's test it to see. Is 10 squared plus 24 squared equal 26 squared? We know it should work, but does it? All right, so we're going to quickly plug that in our calculator. So we get 676 here, and does that equal 26 squared? Bingo. So there's one scenario. So let's try another scenario. It says 14 has to be in it. So if 14 has to be in it, that means that x is going to equal 7. So if x is 7, 7 squared is 49. 49 minus 1 is 48. 49 minus 1 is 50. All right. So 14 squared plus 48 squared, does it equal 50 squared? So I'm going to quickly plug that in my calculator and see if that is true. You should do the same. And 2500 does equal 2500. So the part they said the hardest part is explain. We need to explain why this works. So we are explaining why an even integer must be part of a Pythagorean triple. And the reason for that is since side, we called it A, is 2x, any input for x will result in an even number. Huh? Well, if I take an odd number and multiply it by an even, I'm going to get an even. If I take an even number and multiply it by an even, I'm going to get an even. Ooh. So, why can't I use 2? All right. So if A equals 2, so if this side is 2, then x equals 1. So side B would equal 0. And that's an and. That's not possible. Because can you have a triangle with side 0? Nope. All right. Last one. And again, this should not be totally unfamiliar to us. Maybe asking us to prove it is stretching our algebra a little bit, but we can do this. It's the last one. So consider the polynomial identity. There it is. Prove this identity by expanding the left-hand side of the equation, and then use our calculator to find the value of 11 to the third, and then use the identity to show the same result. Carefully consider your choices for A and B. All right. So why don't you pause the video and try this one on your own, and then start again when you are confident in your answers to check your work. All right, there's my crazy work. So I took this left side and I expanded A plus B 3 times. I multiplied the first 2 in the first box and got this answer. Then I took that answer and multiplied it by the third one, and that's what this box is. I combined my like terms and bingo, got the right side. Therefore, I proved the identity. In part B, I plugged 11 cubed in my calculator and got 1,331. I decided that 11 is 10 plus 1, so 10 plus 1 in parentheses cubed, plugged it into the formula, got the same answer. Perfect. All right, if you have any questions on identities, please don't hesitate to ask. Good luck.